So we're going to continue on that topic. Array lists are not the only collection. Linked lists are another collection. What is a linked list? Well, that would be a data structures class if we talked about how to program a linked list. But fortunately, we don't have to program it. We just get to use theirs. What it does is it's a chain of references. So that, well, if you were going to you might have an element class which had, and this is obviously in Notepad, it had some kind of data and it had a reference to another element. And then there would be a first which would point to the first element in it. And each time you inserted a new piece of data, like say we insert element 1, then the first is now element 1 at whatever address this is. Doesn't matter what address that is. And so element 1 has a piece of data, whatever it is, like the name Joe, and right now the next element in it is null. Doesn't have a second element. Then we add another one. Well, that doesn't affect the reference to the first one, but it jumps to 454. It sees that, okay, there's nothing else to jump to, and so it creates another one. It sets the next pointer of the last one equal to this one. And then it puts, the new piece of name, Bob, in this one, and the next reference for this one is null. We do the same thing. We want to insert the name Fred. Starts here, jumps here. Nope, that's not it. Go to the next element. Nope, that's not it. Hit null. Okay, we're done. That means that we need to insert it. So create another one at a different memory address. And this was Fred. He's pointing to null. But this one is now pointing to that one. Hope this is making sense, right? And so that's the address of the next element in the list. So if you want to access an element in the list, your code looks for the first reference and it hops there, and then it follows the next reference, and it follows the next reference, and so on. What if you wanted to delete Bob from your list? What you got to do is you got to say, okay, we're going to remove. First you search the entire list until you find Bob, and this is the one we want to remove. So we're going to take this next pointer and point it here. Now nothing is pointing to this one anymore. It's gone. And so the next time we wanted to print out the linked list or something like that, we would jump to the first record. Right? What if you wanted to delete Joe? Well, it would jump to the first record. Aha, I already found my match. And so it would copy that value there, and then now nothing is pointing to this element. So it gets deleted. Now we only have one element in our list. So we delete Fred. So it jumps to the first element, which is at 2, 3, 4, 5. Yep, we have a match. So copy the next reference into the first reference. Now nothing is pointing towards this. And we know we have an empty list because the first reference is null. That's the way a linked list works. So A is pointing to B, B is pointing to C, and this one is a doubly linked list to where they're pointing backwards as well. Why would you do that? So that you wouldn't have to start at the very beginning every time. If you were sitting on element C, you could just start working your way backwards. And so when you insert, you have to update your next and your previous pointers. And then when you remove them, you do just what I showed you. You copy the next into the previous pointer, and you copy the previous into the next, and that isolates that one and it gets deleted. So the list interface. ArrayList and LinkedList implements many of the same methods, like get, set, add, remove, clear, and size. they both implement the same list interface. That means, since they both implement the same list interface, they use the same commands. And the word implements means that the class promises to implement all the methods specified by the interface. Well, let's make our own interface. An interface looks like a class, but it just has some method specifications in it. So up above main, did I tell it not to create the main class? I thought I was just telling it to skip the package. Yeah, I skipped that. Please do create the main class, just don't add the package statement. Thanks. Alright, so up here we're going to define an interface, and we're going to say that every shape has a getSurfaceArea method, and every shape has a getVolume method. So interface, instead of the class keyword, the interface keyword. And we give it a name, shape. And we're going to say that every shape has public double getVolume. That's enough. That's enough, right? But we don't actually need to define it. The classes that implement the shape interface are the things that have to define getVolume. So we're going to define a method called cube. A class called cube, which is a shape. So class cube, and here's our new special keyword, implements shape. Now we've already got an error. I mean, we could put a piece of data in here like, double, side length, whatever. But it's complaining. It's complaining because this implement shape is a guarantee that this class will have a method for every method that's listed in the interface, and it doesn't. It wants one. That's why there's an error here. Cube is not abstract and does not override abstract method. Okay, well, that's a little bit more sophisticated. We don't know what an abstract method is, but if I do this, implement all abstract methods, we will see that it adds a getVolume method. It doesn't do anything. It generates an error. So I could have done that by hand easily. I could have just taken this header right here, copied it, and pasted it, deleted the semicolon, and just for now I'm going to make it return 0, right? Because I feel like, no, it could return, side to the power of 3. That wouldn't be a big deal. Why not? So return math.pow side, or this dot side, comma 3, right? Because that's the formula for the volume of a cube. And it wants us to add the override tag, so I will. Okay, when we had that error saying does not implement abstract method, this is an abstract method because it doesn't have a body, right? What is it? It's just a header. If you've taken C++, it's called a prototype. That's a prototype for a method, but the method is not defined except down here in the class that implements the shape interface. So let's make another one that supports the same. So we're going to say class sphere, and it has a radius, double radius. We're going to add well, we don't have to do the add override. It's happy to do that for us. What does that override tag mean? I think I've mentioned this before, but it means if we've made a mistake in the way this is declared, like I said that this was not a double, that it was an int, it complains because now this is not overriding an abstract method. Right? It's telling me, yo, go check your definitions, make sure that they exactly match. And of course they don't exactly match. Let me undo that change. Okay, so this one needs to have a getVolume method as well if it implements the shape interface, which it does, or it will, implements shape. And again, we just need to copy the header, the abstract method, paste it, and the needs to return 4/3 pi r cubed. Return 4.0 divided by 3.0 times math.pi times pi r cubed. Math.pow this dot radius comma 3. Okay. Now we have two classes, and a little warning, yes please, add the override annotation, not necessary, it's just to stop you from running into your own problems by making a mistake in the definition of it. I'm going to do a little bit of stuff just to make it all fit on one page. Not necessary. Right. There. Alright, so down in main, I'm going to use those two classes. Can I expand this so that it fills up the whole window? I don't see how. Alright, so I'm going to create a cube and I'm going to create a sphere. Cube S1 for shape 1 equals new cube, parentheses in parentheses, and let's set the side value. S1 dot side equals 10. So it's a 10 by 10 by 10 cube. Alrighty, how about the next one? Sphere S2 equals new sphere, parentheses in parentheses. It doesn't have a side, it has a radius. S1 dot radius 10. Excuse me, that's not a setter. Set 1 S1 dot radius equals 10. And yes, I should go and add getters and setters for radius and side. Now what are you complaining about? Oh, because I said S2 and I made that S1? That was dumb. Fix that. And what are we going to do with these? We know that both of these have a get volume method. So let's just stick them into an array or an array list. Let's do an array list. We're going to have to import java.util up at the top. But array list less than shape, because everything we're putting into it is a shape, regardless of whether it's a cube or a sphere, greater than. Let's give this a name. How about we just call this shapes? Or shape list equals new array, capital A, list, capital L, less than, greater than. I remember from the PowerPoint on Tuesday, they called that the diamond operator. Yeah, alright, so there we go. And it's complaining it doesn't know what array list is because we haven't imported java.util.asterisk. I think Shannon's just adding that as a matter of course every time she opens a file. Not a bad idea. So you saw what I did. If you still have the package keyword in your file, does the import come above or below the package? Just a question. Who didn't delete the package? Nope. Alright. So anyways, now we have a shape, and let's add our shapes to our shape list. Shape underscore list dot add parentheses S1 in parentheses semicolon. Don't put a backslash there like I accidentally did. Shape underscore list dot add parentheses S2 in parentheses semicolon. What are you complaining about? The collection is only added to. Yeah, I know that. Alright, and now we're going to make a for each loop that goes and prints the volume of each shape. And it knows that it can call the get volume method because it's guaranteed to. Every shape has to have a get volume method if it has that word, implement shape. So, good old for each. For parentheses shape sh, whatever, colon, shape underscore list. So for every shape in the shape list, let's print out system.out.println parentheses quote volume of shape equals space end quote plus sh dot get volume. Just like that. And now it's going to print out the volume of each one, even though the volume of each one is calculated completely different, even though shape does not know how to calculate the volume. Shape dictates, though, that everything that implements it is going to have a get volume method. What if we wanted to change the radius as we were going along? Don't type this because it's not going to work. sh dot radius equals 10. That doesn't work because shape does not have a radius, right? Only spheres have radius. And the compiler doesn't know whether the shape we're referring to has a radius or a side length. And as a matter of fact, right, when the cube comes down the pipe, it's not going to have a radius. So that would flat out be an error. And there we go. The volume of a shape is whatever, and the volume of that shape is whatever. And we could make this cooler and add a toString method that would print out that it was a sphere and the other one was a cube, you know, and do cool stuff like that. But I hope that illustrates the point of what an interface is. An interface is, something that dictates abstract methods, which are headers without bodies. And if you use the implements keyword, you have to go in and provide a body for each one of those methods. So why we get off on that is because an ArrayList and a LinkedList have the same methods because they both implement the list interface. I'm not going to even spend much time on the list interface because you can create a list interface and an ArrayList just the same way. LinkedList and ArrayList performance. With a linked list, it's easiest, it's fastest to find, add, or remove elements because they're doubly linked, right? An ArrayList is not doubly linked, so if you want to delete something from the middle, it has to start at the beginning. However, finding an indexed element is much slower in the linked list because instead of jumping right to the index position, the computer has to go 1, 2, 3, 4, 5. Have to go down the list like that. Whereas behind the scenes, and I don't know how they do this, an ArrayList has an array behind the scenes full of indexes. And so they must be doing some kind of black magic in order to treat that array as an array list behind the scenes. I guess when they fill up that array, they do what I've been talking about, which is, you know, delete the old one, copy all the elements into the new one. So measuring execution time. Measure the average time to get each element at a random index and then set each element at a different random index. Assume a get indices length helper method that returns an array of all integers between 0 and length. Not seeing the part where we start actually measuring. Here we go. You use system.nanotime to get the number of nanoseconds. And then you could measure the performance of this. Time 0 is equal to the current time 1 is equal to the current time. The total number of nanoseconds that it took to execute would be that minus that. Let's see if we can play with that, just for funsies. Let's just print out like 100 elements in a row and print how long it took, rather than do this one, you know. So the number of nanoseconds is a long. So down here, I'm going to go ahead and make a long time 1, comma time 2, or I could call it start and end time, right? That might be a little bit more clear. And then time 1 equals system.nano, all lowercase, time, uppercase. And then let's just do something that takes some time. Whatever. Printing to the screen takes a long time, so why not? For parentheses, int I equals 0, I less than 500, semicolon, I plus plus. Let's just print out 500 numbers. System.out.println, parentheses, in parentheses, semicolon. Let's just print out I. Like that. Now let's get the time after that loop is executed. Time 2 equals capital S system dot nano capital T time, parentheses in parentheses. And now we can calculate the difference. The time took, right? So long, and let's not even do that. Let's just say system.out.println, the loop took, space end quote, plus, parentheses, time 2 minus time 1 in parentheses, plus, quote, space, nanoseconds, period, end quote, in parentheses, semicolon. Like that. And since I don't have the array window on screen, it might run pretty quickly. Don't know, but let's find out. Oh, there it goes. Well, that's a lot of nanoseconds. I don't know if I believe that it ran that quickly. What if I lower the loop to just be 10? I mean, it's a billionth of a second, so, you know, it is a pretty short amount of time, so maybe that's legit. Okay, yeah, a much smaller number of nanoseconds. If we want to convert that to, like, seconds, we would divide it by 10 to the 9. Let's try that, just for funsies. So we actually should have stored that in a variable so that we could, you know, divide it by 1E9. And we're just going to make that say seconds. All right, a very small number of seconds. If we wanted to make it say milliseconds, we would divide it by 1e to the 6. Stop doing that. So milliseconds, M-I-L-L-I-S-E-N-C, and divide it by 1e to the 6. All right, so it took half a millisecond to loop 10 times. And if I go back and make it back to 500 or 1,000, it's going to take longer, of course. Took 48 milliseconds to print 1,000 numbers. Now, printing is about the slowest thing that you can do on a computer. Well, I won't really say that, but it actually takes time, and if we weren't printing anything, that loop would run incredibly fast. Like if we did this, if we put a curly brace there, but we commented out our print statement, bless you, and put a closed curly brace there, it's not going to take half a millisecond anymore, right? So it ran how many times faster? 10 times, 100 times, 10 times, 100 times, it ran like 1,000 times faster, or at least 100 times faster. My brain's not working right. But it ran, you know, considerably faster because it wasn't printing anything on the screen. So now that we have that array list, let's get some of the elements out of it. Shape S equals shape underscore list dot get parentheses 0 and parentheses semicolon. And then we can get the volume out if we so chose. System.out.println parentheses quote volume equals end quote plus S dot get volume in parentheses semicolon. That's great. That's going to work. What if the thing didn't have any data in it? What if we had deleted it? What if we'd wiped out all the data before we ran it? What if I did this? Shape list underscore list dot clear parentheses in parentheses. Now it's going to blow up. We need to start learning techniques for handling exceptions. What does that do when it blows up? It generates a java.lang.index out of bounds exception. I'm going to copy that whole dang thing from there to there because it's a lot to type, and I'm going to enclose my code in a try-catch block. This is the line that can blow up. So I'm going to do this. Try, and on the next line, curly brace, except these two lines need to be inside the block. And now there's an error here saying that there's no catch. Sometimes it offers to fill it in. So anyways, catch, parentheses, and then paste that thing that we copied from the output. Java.lang.index out of bounds exception. Space EX, just for exception. And there we go. Now java.lang is imported by default, so I could actually delete that and just make it say index out of bounds exception. It'll still compile. And we better print a message saying that item does not exist, or whatever, right? System.out.println parentheses specified shape does not exist in list. Some kind of error message, right? Now it's not going to crash. Specified shape does not exist in class. So through exception handling, we caught the runtime error. But there's more runtime errors than that, right? The easiest way to get a runtime error is to do something like this. Int x is equal to 0. Double y is equal to 1 over x. Okay, we're dividing by 0. That's going to blow up. Or not.
I think it found one error first and just kicked out.
Oh, it found the first error. You're correct. It found the first error, so it did not do that. Cut those lines and move them above the .get. Now, we probably wouldn't be doing integer division here anyways, and if you're doing floating point division, divide by 0 doesn't crash the program and instead generates a not a value indicator. But here we go, right? A new error has crept up. Arithmetic exception. So I'm going to copy that. And I'm going to add a catch for that as well. Catch, parentheses, arithmetic exception. If you like typing it, that's a capital A and a capital E. Arithmetic exception EX. And I'm just going to copy my error message and change the text of it, being lazy, or at least copy the print line stuff. Okay. Please don't divide by 0. Sad face. All right, obviously you're not going to put that error message in your code. People have gotten fired because they put funny error messages in their code that they thought the user would never see, and then the user did find it. Like if you had an ATM message or you accidentally printed out insulting statements on somebody's bill. All right, please don't divide by 0. So we could chain a whole bunch of catches. But what if there was one thing that needed to be done regardless of whether an error was caught or not? You can use the finally keyword, and not every language has this. C++ does not. Finally, after you do all that stuff, system.out.println, quote, whew, that was hard. it's a very good question to ask why you just didn't put that right here. Right? Because then it would get done whether an error was caught or not anyways. And there is a reason for it, but so whether it caught an exception or not, it's going to print, whew, that was hard. Right? We could comment this out, and it would no longer generate the divide by zero exception. If we did not clear the shape list, it's no longer going to generate those errors. And so it printed out the volume of that shape, and it said, whew, that was hard. Now, why is there a finally when it would supposedly work just as well if that was outside of it altogether? And that's true. It would work just as well without that. But, and this is weird, if you have a return statement, like here, you just want to return because we caught an error. Before it returns, it jumps down here and it does everything in the finally block because it has to do it regardless of an error or not. And then when it's executed the finally block, it comes up and it does the return. Whereas if this statement was here, it wouldn't run down here, run that, and then run back up here and return. So that's just bizarre, but that's the way that it works. That's what a finally block is for, is to handle things that need to be done, whether an exception occurs or not, if you're going to be returning out of one of these chunks of code. If you're not, you may as well just stick it down there at the bottom and get rid of that finally block. All right, I'm going to get rid of a few things. I'm going to delete that line because it's cluttering up the mistakes. I think I'll leave this one in, the clearing of the shape list, just to generate one of the exceptions. And I need to delete that return line. It's complaining about it anyways. Unnecessary return statement. Why is it saying that? Because there's nothing after this point. So it was going to return anyways. So this is the end of main. You know what I like to do here while I'm looking at it, and that's the end of the class. Get rid of that return statement. Hope I didn't make too many changes on y'all. That's what our try-catch block looks like. So, do we have to enclose all of our divisions in try-catch blocks in order to ensure that divide by zero doesn't happen? No, we haven't ever had to put try-catch in there before. If we were really worried about it, we could have just had if x equals 0, print error message. This is what's known as an unchecked exception, or it generates what is known as an unchecked exception. An unchecked exception is one that gets generated, that you don't have to catch. It's not mandatory to put a try-catch block around it, right? We haven't put try-catch blocks around our division. We don't have to. If you want to, great. Unchecked could be thought of as non-mandatory. There are other operations, file I/O operations, opening a file and reading or writing from it, that the exceptions that they make are called checked exceptions. And when you hear checked exceptions, think mandatory. Your code won't even compile unless you put the code that's opening and writing to the file inside a try. Why? Because saving to a file is fraught with errors. You need to be able to handle the problems, right? Could be a bad file name, maybe the disk is full, maybe the drive, has been unplugged. There could be all sorts of reasons why opening a file would fail. And so to accommodate the fact that there's so many different ways for it to fail, the developers of the file class made it throw checked exceptions, which were mandatory for you to handle. Won't compile if you don't. Queues. What is a queue? A queue is something where everything you insert into it, and then when you start removing items from it, it's just like a line into a theater. You add items to the back, and then you take items out from the front. Or you can think of a reverse, either way. It's just a line so that when you insert something into it, you inserted element A and B and C. And so when you start removing them, A gets taken care of first, just like the first person in line, and B and C are left. And then if somebody new gets in line, D gets in line, they're sitting there, but the next person we're going to process would be B. So let's implement our own list class rather than use theirs, just for the fun of doing something with an array list. We're going to make a class called MyQ, or MQ, implementing our own class. So I'm going to come up here and somewhere, above my class MQ, short for MyQ. And it needs a piece of data. It needs an array list. MyQ is going to support integers, let's just say. So, private array list, capital A, capital L, less than, int, excuse me, why would that fail? Why would that be a syntax error? This is a primitive data type. Has to be the whole word integer. And then let's just call it data. Equals new array list, less than, greater than, open parentheses, close, semicolon. So we're going to add two methods to it. Excuse me for cheating. I'm going to go and look to see what they call it when they do it. They do add, and then they do remove. I don't feel like calling them add and remove. Let's call them add and get. We're going to add items, and then we're going to get items. A queue is a first in, first out data structure, or abstract data type. Collection, I should call it. It's an abstract, it's a first in, first out collection. Meaning that the first person in line gets handled first, the second person in line gets handled second. So we need an add to our queue. Public, and I'm not going to make a return anything, so public void add, parentheses in parentheses. And what does it do? It takes a value, int space x, and it just adds it to the array list. Array list, data.add, parentheses, x, in parentheses, semicolon. So that's going to keep extending the list. What do we need to do here? We're going to write a get. Since we are adding to the end of the list, we need to get from the beginning of the list. Right? You keep piling more people into the end of the line, but you can only take them out from the beginning. And it needs to return an int, because that's the kind of data we're playing with. Public int get. A lot of books call them NQ and DQ, like NQ and DQ. We could do that, but I'm just going to leave it as add and get. All right, it's not going to take any parameters because it's just going to get the first element on the list. So int r for return value is equal to array list, no, I keep doing that, data dot get element 0, the first item in the list. And then we need to delete that item, right? We've taken care of that person in line. They went in the movie theater. They're not in line anymore. So data dot remove 0, first element. And then let's return R. Well, we didn't actually add anything to it, so all that did is prove that there weren't any syntax errors. Append to end of list, get and remove from beginning of list. So let's go to main, create a MyQ, and start adding some items to it and then getting them. So above cube S1, or wherever you want to in your main method, maybe do the same thing I did before. Just shrink the amount of space that this takes on the screen. Okay, so down here, MQ, myQ, equals new MQ, parentheses, in parentheses. Let's add some numbers to it. MyQ dot add a 10 to it. MyQ dot add a 20 to it. And MyQ dot misspelled MyQUE dot add a 30 to it. And then let's get those pieces of data. Int value, value equals myQ dot get, parentheses in parentheses, and let's print that out. System dot out dot println, parentheses. We just got space end quote plus value. And I'm just going to copy those two statements and paste them 2 more times because we added 3 values. We're going to get 3 values. And we're going to print them out. And they're going to be in the same order, 10, 20, 30. And there they go, 10, 20, 30. Great. What if we accidentally got too many? What if I pasted one more? It's going to blow up. Why? Out of bounds exception. There was no item 0. By the time after we got the 3rd element and removed it, there was no data left in the list. So what should we do? Is that okay? Well, I guess it's okay. But we should provide a way for the calling code to find out whether the list is empty or not. So let's add an isEmpty method. So underneath here, along with get, add, and whatever, public boolean is, capital E, empty, parentheses in parentheses. And we're just going to check to see if its size is 0. If data dot size, parentheses in parentheses, equals 0, then return true. Otherwise, return false. Now you could actually do that in just one line of code, right? You could, instead of if, you could just say return parentheses data dot size equals 0 in parentheses. It'd be just as good. So we could put our little bit of code down there in a while loop and keep running while it's not empty. And if we're going to do that, we don't need all these gets. We only need a pair of them, right? We only need one get and one print. But we're going to put it in a while loop. While, parentheses, myQ dot get, dot is empty, parentheses in parentheses, equals false. And that's kind of amateurish. We don't have to do it that way. It looks good to me. But instead, I'm going to do it the better way, which is put the exclamation mark in front of it. So while parentheses, exclamation mark, myQ is empty. Go ahead and get and read. There we go. Now it's not going to generate a syntax error, and it's going to print the 3 numbers. And we could keep on improving it, right? But mostly we're just going to be mimicking the methods that are already in ArrayList. Like we could make a dot size, right? We could just return dot size. Can't think of anything else that we really need to add to it. We have now successfully created a queue. First in, first out, FIFO. So somewhere in here I need to make some notes. Don't care where. A queue is first in, first out, FIFO. The first item added is the first item retrieved. But there's another kind, a stack. And just like a stack of plates, if you have a stack of plates and you're putting things on top of it, when you start getting the plates back off the list, unless you dig down underneath it, the last thing you added to the stack is the first thing you get off. So a stack is last in, first out. LIFO. So the first item, the last item added is the first item removed. Any syntax errors? Everybody good? How you doing, Shannon? Y'all okay? Alrighty. So there we go. If we wanted to change our stack to a queue, it'd be really, really easy. .get, instead of returning the first item, we just need to return the last and remove the last item. And how would you get the number of the last item? You could just call .size and subtract 1 from it, right? Because if the size is 8, you're going to get and remove element 7, because that's the end of the list, 0 through 7. What's this doing? Oh, it's offering to tidy that up. No, I don't want to do that. I'm not going to use isEmpty. I mean, I guess I could, but I like to have, I put .size in there for a reason. Just to remind you that it exists. So a queue is first in, first out. There are different data structures that implement the queue class. Some of them are so-called thread safe. A thread safe is a version of the queue that locks the memory while it's accessing it, just in case you have two separate threads of execution in the same program trying to get that data. Otherwise, they could be fighting each other, and one could be inserting and one could be deleting, and they would mess up. So if you lock, right, the data from one thread, then the other one just has to sit and wait until the first thread releases it. And so that's thread safe. So let's go and just Google thread safe queue Python. See what it coughs up. A queue is a synchronized queue class. Synchronized means that it works in multiple threads. So I would not use the DQ list, the DQ class. I would, wait, that's for Python. Why am I doing it? Derp. Alrighty. A blocking queue. That's what we would use if we cared about having multiple threads of access trying to access our memory at the same time. And you can see that there's all sorts of different kinds. I don't know what the difference between a blocking queue and a concurrent linked queue is, and so on. You could read about it. Are all queues in Java thread safe? There exist many implementations. Linked lists, blocking queues, are all of them thread safe? If your answer is no, which implementation supports? When you read the Java docs of the prospective classes, what exactly confused you in their wording? Alright, so most standard collections are not thread safe. And we could go and we could look at the linked list. And if you needed thread safe versions of stack and queue and stuff like that, we can go and read the documentation about it. A stack is a last in, first out. You push and pop. Those are the methods that they give the name to, or at least the actions that they do. Let's make sure that that's actually what they do. So each time they get a new license plate to add to this list here, if they're adding it, oh come on, where's the actual code? Like that. Push adds a car to our parking lot class. And how about removing a car, get car, pops. So if you wanted to change that myQ class we wrote into a myStack, you would need to change the name of add to pop, change the name of get, add would be push, change the name of get to pop, and have pop get and remove the last element in the list rather than the first. How do you calculate the index? The index would just be size minus 1. So what's a real-world example of a stack? Last in, first out. An undo feature is a stack, right? Because if you add 3 sentences or 3 words to your document, and then you undo it, the first thing that should be changed, that should be removed, is the last thing you did, right? So if you make 3 edits and then you decide you want to undo them, they should undo the last one and then the middle of the last one and then the first one. So undo actions in applications are implemented with stacks. And stacks are used in computer science when you're creating compilers and creating parsers and stuff like that. But when you're doing normal application programming, you're probably not going to use the stack class. Normally you're going to be using lists, right? Array lists. Another collection that's extraordinarily useful, Python called them dictionaries, but Java calls them maps. And that way you can map a set of keys to their values. And we will talk about that, but not today. So the Java Collections Framework gives us a whole bunch of different things we can play with. It's an interface that guarantees the collection hierarchy includes a special kind of queue called a priority queue, which inserts higher priority elements closer to the head of the queue. That's pretty neat. That'd be like a line. The line at the airport where they say all the first class passengers get to get in line first, you know. But then even if you weren't first, you could take cuts if you were a first class passenger. That'd be kind of neat. And then there's the map. The map uses a unique key, like an ID number, to provide rapid access to other more complex objects. The interface collections got a whole bunch of things. Sets. What are sets? Sets are unordered pairs of values, or unordered lists of values, right? Whereas an array list has an order, a set does not. And then you could get the union of those 2 sets. If you're feeling all mathy, those terms make sense. An array list is an implementation of the list interface. And then there's the queue, then the priority queue implements the queue interface. And then there's the deck, double-ended queue. And a linked list is an implementation of the list class. Whereas an array DQ also has an implementation. Well, check this out. This bad boy presents himself as both being a queue and a list, because he has 2 different arrows going up. So of the maps, there are sorted maps and then there are unsorted maps, called a linked hash map. What's a sorted map? Sorted maps are cool because then as you iterate through them to print the data out, all the keys would be in order. And what do I mean by keys? If you have a dictionary, right, the word axe comes before the word bridle, which comes before the word cat. And so if we kept adding these things in, to our dictionary along with some definition for them or some number, or maybe their cost. I don't know. You know, an axe costs $4.99, and a bridle costs, you know, $18.42, and cats are incredibly expensive, so they cost, you know, almost $5,000. There you go. If you stepped through the map, it would give you these items in order. If it is a sorted map. If it's an unsorted map, then you have no guarantee that when you access the items with a for loop or anything like that, that they'll come out in the same order. These won't necessarily be alphabetized. We're about done for today, because I don't want to do a map example. It's important enough to spend much more time than 2 minutes on. Okay, so we're going to stop there. And lo and behold, as you might have guessed since I typed this in, that's the homework, is to take the MyQ class and turn it into MyStack. Make the changes. Change the name of add to push, change the name of get to pop, and have pop get and remove. Then use your MyStack class to add 3 elements. I should say push 3 integers, to pop 1, push 3 more, pop another one, and then enter a loop that pops until empty, until the stack is empty. And when I say pop, I actually want you to get the value and then print it out. So I'm going to say pop and print 1. Push 3 more, pop and print 1. Right? And then enter a loop that pops and prints until the stack is empty. That makes sense? The reason I want you to do that is that loop is going to show you what's left on the stack after you've popped a couple of them, because they're going to go in reverse order, right? If we add, and sorry guys watching this at home, we add items 1, 2, and 3, and then we pop 1, that one's going to be gone. The 3 is going to be gone. And then we add 3 more values, 4, 5, and 6, and we pop 1. That's what's left. And then when we have our list, our loop that pops them all, it's going to print 5, 4, 2, and 1. And so if you add the items in order, like that, and you follow the pops that I just said, that would be your output, 5, 4, 2, 1. All righty. Does that make sense, gang?